limits, all you have to do is plug in the value of x that you've been given. So in this case, you're going to have 2 squared minus 2 multiplied by 2 minus 3. So this will reduce to what? This will reduce to 4 minus 4 minus 3. And your answer will be negative 3. So that is the limit as x approaches 2 for that function. There may be some cases where plugging in direct substitution may not work because you may have something that is undefined. Okay, for example, let's say you've been asked to determine the limit as x approaches negative 1 for x squared minus 1 over x plus 1. So if you look closely at this function, if you plug in negative 1 there, it's going to be x squared minus 1 over what? Negative 1 plus 1, which will give us the denominator is going to be 0. And whenever you have that expression in mathematics, it means that it is undefined. Okay, so we don't want to have something that is going to be undefined. So then how should we do it? So it's very important to understand the different ways in which we can do away with the denominator so that we don't have something to be undefined. So in this case, if you look at the numerator, it is a difference of 2 squares. So for example, when you have got x squared minus 4, this is the same as x squared minus 2 squared, which can be expressed in terms of x minus 2, again x plus 2. So if you look closely at what we have got x squared minus 1. So 1 is the same as what? 1 squared, and we can square it. So our 1 is the same as 1 squared. So our limit as x approaches negative 1 is going to be x minus 1. Then the other one is going to be x plus 1 over what? X plus 1. At this point, we're able to see that the denominator is actually equivalent to one of the factors, so we can divide. So you now have the limit as x approaches negative 1, x minus 1. So at this point, when you plug in the value of x there, the function won't be undefined. So negative 1 minus 1 is going to be negative 2, and therefore that becomes our solution. So the limit there is negative 2. Let's say you have limits as x approaches 3 for the function x squared minus 2x minus 3 divided by x minus 3. So what happens when you plug in the value of x? So it's going to be undefined as well. So we need to factorize the numerator. So x squared minus 2x minus 3. I'll run you through a procedure of factorizing that. So the product, the sum, and the factors. So the product is determined as a product. The product is the product of the coefficient of x squared and the coefficient, which is and the constant, which is negative 3. The sum is the b part, which is negative 2. So the factors, what numbers can we multiply to give us negative 3? When you add them, they give you negative 2. It's basically negative 3 and 1. So this will become x squared. So the middle part is going to be substituted by the factors with the variable x. So minus 3x plus x minus 3. So what's common there is x. You have x minus 3. There you have 1, x minus 3. So what you have as a factor is x plus 1, x minus 3. So we can substitute this where we have what? Where we have the function on top there. So now what you have is limit as x gets to approach 3. So your numerator will be x plus 1, x minus 3 divided by x minus 3. So at this point again we can see that this is common and it will divide. So you remain with limit as x approaches 3 to just be x plus 1. So at the point where you have x, plug in 3. What are you going to have? You have 4. So that is your limit as x approaches 3 for this function. Next question. Let's say you've been given to determine the limit as determining the limit as x gets to approach positive infinity. So what you have is 2x to the power 3 plus 1 divided by 2 plus x minus 3x to the power 3. So basically infinity, as we may be aware, is not a number, so we can't just plug in direct there because it's going to be complicated. So what do? It's very important to note that infinity is denoting something, a positive, a very big positive number. So think of this. So when you have 1 over x, right? Let's look at 1 over x. Then you've been taught to determine the limit as x approaches positive infinity. So you can try this out. Come up with a table of x and y values. Let's say you start from 10 to the power 6. Look at 10 to the power 9. So you have a million, a billion, 10 to the power maybe 100. So if you plug in there where there's x, so remember that as the values of x are increasing, this function is going to be reducing, because basically if you start from, if we start from 10 to make it easier, if your value of x is 10, your function is going to be give you a value of what? 0.1. If it's 100, 0.01. So as you get to plug in these big figures, you can get a calculator and try that. So you're going to find that your values are going to be having more zeros, and the number will become smaller and smaller. So in that regard, we can come up with a conclusion that as we get to approach a positive or infinity, 1 over x tends to approach what? 0, because the number becomes smaller and smaller. So the limit of x as x approaches infinity, 1 over x, is actually going to be 0, or whatever power may be of the value x there, it is still going to be approaching 0. Okay, so we use that same concept to answer this one. So what we're going to have is we need to make sure that that is expressed in the form of 1 over x. So we can say the limit as x approaches infinity. So we divide by the highest power. So on top, what you have is x to the power 3. So you divide that, 2x to the power 3 divided by x to the power 3. Even the 1 is also supposed to be divided by x to the power 3. The same applies to the denominator. So you need to divide that by the highest power, which is also x to the power 3. So you're going to have 2 over x to the power 3, x over x to the power 3, minus 3x to the power 3 over x to the power 3. So from there, what are we going to have? Let's have some space. So this is going to reduce to the limit as x approaches infinity. So this part you are going to divide. You remain with a 2. So this parts are divided. So x into x is 1. Here it will remain x squared. Here you are going to divide. So what are you remaining with? You are remaining with 2 on the numerator plus 1 over x to the power 3 divided by 2 over x to the power 3 plus 1 over x squared minus 3. So you have the limit as x approaches infinity now. So we can remove this from this side and substitute now. So you have 2. So where this x, we're going to say now as the limit x approaches positive infinity, 1 over x to the power 3 divided by the limit as x approaches infinity for 2 over x to the power 3 plus the limit as x approaches infinity for 1 over x squared minus 3. So notice that you have x as a denominator, and I said it being raised to any power, provided on top what you have is a constant, they are all going to be zeros. Okay, so what do we have now? What we have is 2. So at every point where we have this kind of an expression as a fraction, it's a 0. So it's 2 plus 0 over, so this is a 0, 0, and therefore our answer becomes negative 2 over what? 3. Now let's say you have the limit as x approaches 4, 2 minus root of x divided by x minus 4. So if you look at this function, if you plug in the value of x there, it's going to be 0, so it's going to be undefined, and we've been trying to avoid that. But in this case, you can't factorize what's on top there. So we'd want to find ways and means where we are going to, do away with the x on the bottom. So the best way to simplify this is by multiplying by the conjugate. So when you have 2 minus root of x, the conjugate is 2 plus root of x. So these are sides. You can check for our video on sides. The link is going to be in the description. Okay, so you have 2 plus root of x. So this should also be multiplied by the denominator. So we're just dealing with first sphere first of all. So we are trying to determine the limit as x approaches what? 4. What do you have now? So when you're multiplying a conjugate with this function, so it's just 2 times 2, which is a 4, x times x. So root of x times root of x is x. Okay. So you have minus x over x minus 4 to root of x. This is where it's coming from. So 4 minus x can be expressed in a different form. We can factorize negative 1 there. So if you factorize negative 1, you're going to have x is going to become positive, then the 4 will become negative. So why am I doing that? I want it to appear more like the one that is down so that we cancel it out. So the limit as x approaches 4 is x minus 4 2 plus root of x. So this is going to divide. And what are you going to have? So you now have the limit as x approaches 4, negative 1 over what? 2 plus root of x. There you can now plug in the value of x. So negative 1 over what? 2 plus root of 4. So I've just plugged in now the value of x there because it's not going to be undefined anymore. So what do we have now? So you have negative 1 over, so root of 4 is 2, 2 plus 2 is 4. So this is your limit as x approaches 4 for the given function. And that's it for this video. Thank you very much for watching.